For this problem, we're going to take a look at the area of one leaf of this graph of r is equal to a cosine of 5 theta. Now, before we do this problem, let me talk about just kind of eyeballing an estimate without actually doing any real calculus. I mean, after all, this is an area problem, and so the problem is find the area. This shape is approximately like a rectangle. Okay, so the length of this rectangle goes from 0 to 1. Here's 0.5. So each of these little tick marks is a tenth. And so this looks like a tenth here. So something like a tenth to negative a tenth. If I were to draw that rectangle, that looks like it's about the same area as this leaf mark here. And so the estimate that I would do just eyeballing it would be the length is 1 and the height is 0.2. And so 0.2 would be my estimate. Now, this is not the exact answer by any stretch of the imagination, but this gives me some idea as to what I expect for the final answer. If my answer turns out to be like 0.1 or 0.3, I won't be too surprised because that's kind of near my estimate. However, if I do the calculus and I end up with an answer like 26, that is way off from 0.2. And so I know I must have done a mistake and I should redo the calculation. So this gives me just kind of an eyeball as to some kind of reality check as to what the answer ought to be. Okay, now how do I do this problem? So this leaf is bounded when r is equal to 0. Okay, so when r is equal to 0 is here, then r is not 0, and then it comes back when r is equal to 0 a second time. And so let's figure out where r is equal to 0. Okay, if r is equal to 0, that means that cosine of 5 theta is equal to 0. And cosine is equal to 0 on the half multiples of pi. Or let me write this as 2n plus 1 times pi over 2. And so that means that theta is going to be equal to 2n plus 1 times pi divided by 10. Okay, so plugging in, if I let n equal 0, I would get 1 pi over 10. If I let n equal 1, I would get 2 plus 1, 3 pi over 10. If I were to let n equal 2, I get 5 pi over 10, which is a half pi. And actually, I see that one, 5 pi over 10. That's coming here. I see that as I get closer to pi over 2, the distance is going to be 0. I can also go the other direction. If n is equal to negative 1, I get negative 2 plus 1, so negative pi over 10, negative 3 pi over 10, and so on in the other direction. Okay, and so the area that I will set up will be integral from negative pi over 10 to pi over 10 of 1/2 of cosine of 5 theta squared d theta. That is my formula for finding the area of a region in polar coordinates. Now, I chose this boundary between negative pi over 10 and pi over 10. I could have chosen pi over 10 to 3 pi over 10. That would have been the area here if I had chosen between pi over 10 and 3 pi over 10. If I had, actually, it would have been this region here. If I had chosen between 3 pi over 10 and 5 pi over 10, it would have been this region over here. So any one of these endpoints would have worked as long as I take 2 consecutive times that theta passes through the origin. Okay, now to do this, I employ a trig identity, cosine squared. So I have a trig identity for that to allow me to integral from negative pi over 10 to pi over 10 of 1/2 times 1/2 times 1 plus cosine of 2 times 5 theta or 10 theta d theta. Okay, so now I integrate 1/4, I'll bring outside. Integral of 1 is theta. Integral of sine of 10 theta is 1/10 times the sine of 10 times theta. And I evaluate, upper endpoint is pi over 10, lower endpoint is negative pi over 10. Okay, so plugging in, we get 1/4 times pi over 10 plus 1/10 times the sine of pi. That's one option. Minus the other side, we get negative pi over 10 plus 1/10 times the sine of negative pi. Parentheses, bracket. Okay, sine of pi is 0, sine of negative pi is 0, so I don't have to worry about those. So I end up with 1/4 times pi over 10 plus 0 plus pi over 10 plus another 0. So I end up with pi over 5 times 1/4, which makes pi over 20. And so that is the exact answer. Now, how did I do with my guess? Pi over 20, that's something like 0.15. My guess was 0.2. And so my answer here is indeed reasonably close to the guess that I made by just kind of staring at the area and approximating it by one of our common shapes.